Okay, in this video we're going to look at Formula 7, just continuing on from the 6 from the last 2 days. And this is the identity that you have to prove. Sin A plus B equals sin A cos B plus cos A sin B. Now we're going to use this identity, and this is it is a bit of a memorization that's the one you have to use. So you can see it here, cos A minus B equals now cos A cos B plus sin A sin B. That's the one we're going to use. Now you might look and say, well, that's not sin A. It doesn't align properly, but we're going to make it align properly. Now there's a couple of things here as well in the tables that'll be useful. Cos of minus A equals cos A, sin of minus A equals minus sin A. Now, but one other thing too, I suppose, so we're going to use this, and we're going to replace the angle A with pi over 2 minus A on both sides. So, replace the angle A, so we're going to replace this A with pi over 2 minus A. We're going to replace that A with pi over 2 minus A, and we're going to replace that A with pi over 2 minus A. So you can see there, so we've replaced everywhere you see an A, so there's 1, 2, 3 A's, we're going to replace it with 1, 2, 3. Now, something that you might have discovered yourselves or you may have noticed yourself, it's saying here the cos of pi over 2 minus A equals sin A. Now, as we know, pi over 2 is 90 degrees, so that's expressed in radians. Now, let's just take, for example, let the angle A equals 30 degrees. Well, so cos of 90 take away 30. That would be equal to a half in your calculator. But sin of 30 is also equal to a half. And that's universal the whole way. So sin of 45 is equal to cos of 45. Sin of 70 is, cos of 70 is equal to sin of 20. And sin of 0 is equal to cos of 90. So that's just something that you might have been aware of. Now, however, the proof is not needed for this course, so you just have to accept that cos of pi over 2 minus A equals sin A. And you can use 90 degrees if you want, there's no issue there. Sorry, the camera's just a bit wobbly there. Now, and also, sin of pi over 2 minus A equals cos A. So, for example, sin of 70 is cos of 20. So if you're looking at the angle 20 degrees, sin of 90 take away 20, so that's sin of 70 is equal to cos of 70. Cos of 20, so A is 20. Now, so having done that now, so because of that, we can replace cos, so see this cos here? We can replace that, so it is the same as sin A. So we've taken out this and we've put in sin A. Likewise, we've taken out sin of this and put in cos A. So cos of this is equal to sin A, and sin of this is equal to cos A. So that's just something, yeah, it's annoying, it is a bit of a memorization, this proof, but that's the key there. Those two lines there are the key. That's the little bit of knowledge and learning. Now, we're going to just be a bit creative here. So we're going to, so they just stick in a little bracket here. So cos of pi over 2 minus this. Because remember, cos of pi over 2 minus any angle is equal to sin of that angle. Okay? So cos of pi over 2 minus the angle equals sin of that angle, which is what we want to get up here. Okay? That's what we want to get up here. And then we have the sin A cos B, cos A sin B. So that's one, it's just go over it a few times. So the key thing is you take this identity and you're going to use that identity to turn it into that identity. So cos A, remember, cos A is the same as sin of pi over 2 minus A. So that's where we get it. Listen, it's not the easiest. Now, the good news about Formula 9 is we've already done it. On the 2015 paper 2, question 5, we've already kind of gone through it. So you might remember that tan is the same as sin over cos. Now, so that means that we're going to show that the left-hand side can be turned into the right-hand side. So tan of A plus B would be equal to sin of A plus B over cos of A plus B. Now we use an identity there, sin of a plus b. So in your tables, find an identity for sin of a plus b, and there it is. And then there's an identity then for cos of a plus b. So there's the two identities that we replace. So we're replacing sin of a plus b and cos of a plus b with their two identities. Now, we're going to divide every term by cos a, cos b, simply because if you look here, I have 1, 2, 3, 4 terms. Now, tan a, tan b is one term. This term here is one term. So how, if you look at the term that's in the bottom left, how can I turn, sorry, it's 1. Now look at my term in the bottom left here, because I have 1, 2, 3, 4. How can I turn this into 1? Well, quite simply, how do you turn anything into 1? You divide by cos a, cos b. But you divide every single term by cos a, cos b. So you divide every number in the top by cos a, cos b, and you divide every number in the bottom by cos a, cos b. So then it's sin a, cos b over cos a, cos b. So the cos b's will cancel to leave you with sin a over cos a. And sin a over cos a is the same as tan a. Likewise, cos a over cos a will cancel, and that'll leave you sin b over cos b, which is tan b. And then cos a, cos b over cos a, cos b is 1. And likewise, sin a over cos a is tan a, and sin b over cos b is tan b. So it might maybe make it a little bit easier for you if you were to put like brackets there. So just to say that that's tan a and that's tan b, and that's the proof done. Okay, now I don't like this top one. It's just not a nice one, but listen, that's the 9 trigonometric formula learned off. Hopefully by the end of today. That would be really good work if you could get that done.